James from Envirosun. I'm going to talk a little bit about our AS systems, or we call AS as active systems, or split systems, they're commonly known as in the industry. This varies a little bit from our previous clips that we've done and videos that we've done on our thermosiphon passive system. So an active system is a terminology used that means that a pump or a mechanical device is used to circulate water through the collectors and back into the storage tank, which is the solar energy is then gathered through the collectors and stored into the storage tank. So I'm going to talk a little bit about our product today, how it works. I won't go into too much detail about specific installations, but more or less about what we supply. We'll talk about our products. We have what we consider to be the heart of the product, is a collector. And that's common to both the passive system, the TS model range, both the closed and the open circuit, and also the AS system, which we're going to talk a bit more about today. This product here is a 2BC collector. We have two models in our range, a 2.5 square metre system and a 2 square metre system. Both of these systems have all copper absorber panels. That's the items that you see inside the collector. It's housed in an full aluminium tray, and a low iron toughened glass is put on the outside. Unlike a lot of companies, we use all window sealing systems, EPDM sealing, to make sure that weatherproofing is absolutely integral to the supremacy of this collector. We don't want any water getting inside it, we don't want any weather getting inside it, so it's got to be really sealed from the elements, because what we've got here is a device which actually absorbs energy into it, and we've got to store that energy in the tank. So we need to absorb as much energy as we can. So this product is common to our range. I'm going to show you a little bit about the type of connections we use and what we connect to this for the AS system today. The device is a copper ultrasonically welded fin and tube system, and it's tested to AS2712. The product which we use here, we use worldwide, and we can use in frost areas, we can use in high temperature areas as well, because we do have methods of controlling the temperature. So in that absorber panel I spoke about before is all copper, and what we do is we apply a treatment to that copper absorber panel to make it effective. So to give you an example, if you were just to paint that black paint, you have two critical measurements, we call it absorption and emissivity. And the absorption would be at a very low level, below 50% possibly, and emissivity would be very high, around 40%. So you have a very inefficient product. But what we do with our product is we use a black chrome selective surface deposition onto the copper, and that provides a very high level of absorption, up around about 0.92 or 92%, and a very low emissivity, about 0.7 or thereabouts. And doing that means that you get a lot of absorption into the medium, which is the water passing through the collector, and you get very little re-emissivity back out of it. And this is critical for a high-performing collector. There are a lot of surfaces around the world today which boast this sort of technology, but copper is a tried and true medium, particularly for longevity. And this product here in Australia, particularly with the high abundance of solar radiation, we've got to be a little bit careful that we don't over-collect our energy. We've got to moderate our absorption to the right balance levels of what we're trying to put as an input into the tank. So we think we've matched that reasonably well with all our storage systems, and we can improve on those things with the quantity of collectors we put up there and the size of the collectors. As I said, if you wanted more STCs, we can have a bigger array up there, 5 square metres with 2.5, or we can have the 4 square metre system, which is ideal for locations like here in Perth if you're using it with thermosiphons. But with split systems and AS, we do use a lot of the 2.5s and 2 of those together. Okay, the storage system that we use for our tanks on an AS system are two models: a 400 litre or 420 litre storage, and a 315 litre delivery or a 325 litre storage. This is the 400 litre model. They're basically differentiated because of the height and the dome size that we have, which is the diameter of the cylinder. They all come with a purpose designed solar water heater connection system. So it means that we take our water out of the bottom via a pump, which I'm going to talk a bit about, or pump station we'll talk about later, and return it to the middle of the tank. So we optimise that storage capacity. And up here is the pressure temperature relief valve installed, and on the other side is the cold water in and the hot water out. On a vertical tank, you've got very good stratification, so it means that the water coming into the bottom of it doesn't mix a lot, although inside the tank we still have inlet pipes and scoops to ensure that we don't mix the water and keep it nice and turbulent free. It's important to get out of this cylinder as much hot water as possible that's just stored, so you don't want to mix it up every time you turn on the tap and push cold water in it. These tanks are a displacement hot water cylinder. It means you, by turning on a tap in the house, you're pushing water into it to push water out of it, and that's how a mains pressure displacement tank works. With all these systems, we also have an electric booster, and that's located in the middle of the tank. So again, we don't want to boost the whole tank, we just want to boost half the tank. So we want to maximise our solar input if we can. On something like this, we're still getting over 150 litres of boosting, so in case of bad weather, nighttime use or problems with the solar input, we can always get plenty of hot water through our electric boosting. We provide in each one of these a 2.4 kilowatt element, and again, we always ensure that it's a purpose-made solar thermostat so that we don't have any nuisance tripping or any problems associated with over temperature from the solar energy. Over temperature is one of those things we have to control a lot with the solar, because there's so much uncontrolled heat source there from the solar energy. These products are a vitreous enamel tank. We have these are made in Australia. We have been using these now for many years, and we can install these in just about any location around Australia. Again, you've got to be careful though in frost areas, because freezing conditions can apply to pump systems just as they do with passive systems. The model here is going through a bit of an update lately, so the tanks will have some changes in the next few months, but we'll give you more information as that becomes available.